Programs run into problems and errors all the time, so it's a good practice to have a plan for handling them when they happen. And in Python, one way to do this is through exception handling. So here in my editor, I'm going to open up the exceptions_start file, and I'll start off by writing some code that I know is going to generate an error. So I'll write x equals 10 divided by 0. Now, obviously, divided by 0 is a math error, so when I save and run this, we can see that the program crashes and exits with this division by 0 error message. Now, this is a pretty bad experience for users, and we can do a much better job of handling errors like this in our code by using exception handling. So let's close the terminal. So let's rewrite this by using exceptions. So I'm going to comment that out. I'm going to write try, and then I'm going to do my formula again. Okay, and then I'm going to write except, and I'm going to print. Well, that didn't work. Okay, and we'll save. All right. So within the try section is where I write code that might cause some errors. Python will execute the code as usual, and if anything goes wrong, then the flow of the program transfers immediately to this closest except section here where I can handle the error. So in this case, the divide by 0 error will cause the program to jump to the print statement. So now let's save and let's run this again. And you can see that instead of crashing, my program prints out the custom error message. Well, that didn't work. Now, that's a better experience, but we can improve on this. We can write except sections that handle specific kinds of errors. So let's suppose I have some code in my try section that can cause different kinds of problems. So let me go back and comment out this previous example. So I'm going to write some code in my try section, and I'll have an answer variable that's going to take the result of user input. And it's going to say, what should I divide 10 by? Right? And then the number is going to be the result of casting the answer into an integer, and then I'm going to print 10 divided by whatever number the user gives me. Now, in this case, the user might enter a 0, which would cause a divide by 0 exception, or they might enter some input that isn't a number, which will cause this int function here to fail with a value error exception. So to handle both of these separately, I can write multiple except sections. So the first one will handle the divide by 0 error. So I'll write except 0 division error. And in this case, I'll get a local variable named e, which is the exception, and I'll print out you can't divide by 0. In this case, I won't use the local value e, but in this case, I will. I'll write except value error as e, and I'll print out you didn't give me a valid number, and I'll print out the exception here, just to show that it can be done. And there's also one more section that we can add called a finally section. This section contains code that will always execute regardless of whether an error occurred. And you can use it to clean up any resources that you've allocated, such as open files or other system resources that you're using. So I'm going to write finally, print, this code always runs. All right, so let's save, and I'm going to run my updated code. All right. Okay, so let's go ahead and enter a real number like 2. Okay, we can see that that works, right? So the answer is 5, and we can see that the finally section always runs. Okay, let's run it again. And this time, let's enter something that's not a number so that the int conversion will fail. So I'll just enter blah, and you can see it says you didn't give me a valid number, and then you can see that's printing out the actual exception code right there. And then again, the finally section always runs. And let's run it one more time, and then let's enter 0. And you can see that the 0 division error section is being triggered. So exceptions make error handling a bit easier to read by centralizing the code for dealing with those errors in one place and separating it from the code that does the program's actual work.